All right. Thanks everybody for joining. After a little bit of a gap in our talks, we have two old friends that have given a lot of talks over the years on different topics coming back to talk about some new work that they've been doing. Doug Southworth and Brian Tierney, both representing TACC today. And they're going to be talking a little bit about NetSage and how they've been working on a project with Globus to try to visualize data transfers. So I'm going to turn it over to Brian and Doug to get us started.
All right, thanks, Jason. Appreciate it. It's up here. So yeah, as Jason said, we were fortunate enough to be able to work with Globus and work with them to visualize a lot of the Globus data that basically it's Globus is pretty widely used, but it was really hard to get a handle on just how it was being used, other than raw data totals. And so Globus approached us and asked us if there was a possibility of using NetSage to actually see where transfers were going and what the performance was and those sorts of things. I'm going to start by giving just a quick overview of what NetSage is for anybody who may not have any experience with it. Um, so basically, NetSafe they need to monitor R&E links across the Pacific and across the Atlantic that were NSF grants, originally born out of IRNC grants specifically. And part of that grant requirement was that there was basically data reporting so that there was readily apparent how the links were being used. But as opposed to just giving totals, SNMP counters or raw flow data or something like that, wanted to come up with a way that average people could visualize how the networks were being used. You didn't have to be a trained network engineer to understand how data was flowing between different universities and institutions. So that it was NSF funded. Basically, it was a collaboration between IU, LBNL, and University of Hawaii, who did a lot of the visualization work. Primarily, we're developing that at TACC now, so we're carrying the torch, and it's been in some sort of production now for almost a decade. So what makes NetSage different than a lot of other visualization tools out there is we decided to build it around answering questions, because data by itself, if you have a bunch of network data, that's not necessarily useful. So we tried to anticipate if you were a researcher or a decision maker who wasn't intimately acquainted with the internals of your network, if you had access to this data, how would you use it? What kind of questions would you want answered? And so we built NetSage around a navigation system that basically answers questions that give you a high level overview of how networks are being used. And that's one kind of important point that I'd like to bring out about NetSage is that you can drill down. We're going to give some demos about how specific you can get with the data, but really the goal is to give you readable patterns of data transfers and data transfer performance so that you can then use your own tools to dig a little bit deeper and find out what's really going on if you find something interesting. But to even begin to ask those kinds of questions, you need to have a good high level overview of what's going on in the R&E transfer ecosystem, whether that's we have NetSage at TACC specifically, but also maybe this applies to a regional network. We have regional instances, and there are still international instances that are maintained by Indiana University. So we have NetSage broadly deployed across a bunch of different use cases. So right now, regionally, we have FRGP, GPN, Learn, Pyron, SOCKS, and Sun Corridor Network on board. Fairly recently, just in the past 6 months or so, we now have NetSage looking at Access CI compute resources. So these are Jetstream at IU, they're Anvil at Purdue, at TACC. We're showing everything we have there, but really specifically the access resources like Stampede are the ones that we're interested in. So that Access CI instance gives you information about the top tier resources, and we're actually going to be adding Texas A&M and Stony Brook pretty quick as well. And again, there are international instances that are still maintained by IU as well. So there's a bunch of different places that you can find really interesting network data about where transfers are happening and what the performance looks like. So really quickly, because this is a public resource, we do take privacy seriously. So there are never records of the full IP address associated with any flow data that we have, or in this case, Globus data, like we're going to be talking about today. That's all been de-identified, so it conforms with uh, privacy practices pretty much universally across the United States and even internationally. We've had discussions, we've shown them what our practices are, and we really haven't had any issues with people saying that they believe we're collecting PII. We also do a couple other things to limit what NetSage collects. Specifically, we're not collecting flows that are smaller than 10 megabytes because that eliminates a bunch of flow traffic, small stuff, DNS, emails, that sort of thing. But it also goes towards making sure that privacy is maintained. We're really only interested in the elephant flows, the big stuff out there, and visualizing that performance of those large scientific data flows. So I'm going to do a real quick, let me stop this share and I'm going to switch screens real quick. Just kind of a quick run through of what the new Globus dashboards look like. And then we're going to talk a little bit about what those dashboards look like if you're actually using them to visualize performance and what kind of data you can mine from them. Brian's going to take that over a little bit later in the talk after we talk a few technical details about uh, what we did to make this work with Globus. So this is the way NetSage looks currently. We changed the navigation up. If anybody remembers NetSage before, there was what we lovingly called the spinny S over here. And that navigation system was with us basically up until about a year and a half ago. But with recent changes to Grafana and the way they do business, that's no longer an option. So we've gone to more of a static menu-driven approach. So for anybody who's used NetSage before, a lot of these dashboards will look very, very similar. But you can see the top level question there was very straightforward. What are the top sources and destination of tasks? And that's the language that Globus uses to define a completed set transfer. So however many files that was, whatever, amount of bulk data that was, that is one task. And so that's what we're visualizing here is completed tasks. Time range is up here. You can change this. We've only been collecting fresh data for about a month and a half now, but actually after we got this up and going, Globus sent us a full year of back data. So this archive now goes back to about July 4th, I think, sometime right around July 4th of 2023. So you actually can go back in time already and take a look at transfers. So pick your time range. 7 days is the default, but you can easily change that to 30, 90, 6 months, whatever you want to see. So information on most of these dashboards is arranged by sources and destinations. We show a lot of data by both volume and then by rate, because depending on what you're looking for, one is going to be more interesting than the other. We tend to show data in top pairs as well, and you'll notice as we're doing these demos, you'll see a lot of the same data presented a lot of, let me phrase it this way. You'll see the same data presented in different visual formats because some people are chart people, some people are visual graph people, and so you'll run across the same data kind of presented in different ways that maybe resonates more with one person or another. For instance, we've got our top pairs up here in a chart form, which gives you a little more raw data about what happened. But if you're more of a visual person and want to see who was talking to who and who the heavy hitters were, maybe this type of chart, this line graph appeals more to you. Any navigation once you're here to get back to the home page is as simple as just clicking home, and that'll take you back home. Any link in a table that is highlighted blue like these are means that that will take you somewhere else. So in this case, we're looking at all the organizations that we're accepting Globus data or we're visualizing Globus data for. And if you see one that looks interesting in one of these, you can actually click. Like you notice Purdue is one of our top 25 talkers. If I click on Purdue, that's going to take me to a dashboard that now shows me organizational Globus task transfers only for Purdue. We've also had to add some different functionality to the dashboards because we found in Globus there are things that we don't encounter a lot when we look at flow data. For instance, internal transfers. So this is Purdue as an organization, and one of their top destinations is Purdue, which means they do a lot of internal transfers, probably using Globus to transfer from one DTN resource to another, or jobs in and out of Anvil supercomputer or something along those lines. Up here that allow you to eliminate the internal transfers if you're more interested in seeing outside data. And that toggle exists on all the dashboards just to help you sort and filter based on what you're looking for. One other thing we had to add in was the confidential tasks. Globus has some users that have some proprietary information that needs to be protected, and that includes who they're doing transfers with. We do include them. If you turn this on, you'll notice there's an unavailable here. That just means that we want to see the data totals, but we don't necessarily, we don't have that information from Globus about who that relates to. So we've included it for the sake of thoroughness if you want to get full data totals, but in general, that is turned off by default. So we're just looking at research and education traffic. Um, there's a bunch of different ways to visualize things here. There's a bunch of pages like that that show between organizations, between um, entities. We've got one that's by country, which does exactly what you would assume it would do. It show you transfers by from country to country. Um, we also have some different ones if you're more interested in looking at patterns over time. This one's kind of an interesting one if you're trying to visualize what Globus data looks like over a period of time and how it's changed, how different users have kind of come and gone. And so sometimes you have consistent top performers like Oak Ridge, one of the biggest users on a very, very consistent basis. But if you go down here, you've got NIH, which is kind of there and then gone, and then there and then gone. And so you can kind of pick out different interesting transfer patterns as projects have an ebb and flow to them, and different users come and go. So that's a really basic overview of navigation here. I'm not going to go any more in depth than that simply because Brian has got a really, really cool demo coming up where he's going to show off a lot of the dashboard features, and I don't want to steal his thunder there. So let me get back to the slides real quick. Okay, so what we had to do to make this work. Well, let me actually share the screen. That would help. There we go. So most of the basically a quick overview of how NetSage works is NetSage on the consumer side effectively, or well, I guess TACC would be the consumer side. On the side that's giving us flow data, whether that's a regional network or an international network or something like that, wherever we're collecting data from, it's a set of Docker containers that basically collects flow data. It writes out NFCap files from the collector. The importer then looks in a specific directory or set of directories for those NFCat files and then takes those and through a series of currently custom Perl scripts, reformats that data and preps it for something that Logstash will understand. And then that gets dumped into a RabbitMQ just because we need to buffer Logstash to make sure it doesn't get overwhelmed by sudden bursts of flow data. Logstash goes through and adds a bunch of metadata to enrich with, organizational name and latitude, longitude, a bunch of different data that we throw in there as well that aids in the visualizations and the dashboards themselves. And then we've got a small manager container that basically runs jobs against the other containers for restarts and updating different resources that it needs. After all that happens, it gets sent out to the Elasticsearch database, which is actually at TACC. So all the flow data, all the Globus data, all the SNMP data that we have is in an Elasticsearch cluster that lives at TACC. And then we visualize all that front end with Grafana.
Hey,
So the
Doug,
pipeline, yeah.
we had a question come in.
Oh, sure.
Is the importer a custom built application that you just talked about?
Yes. So the importer is actually, it's part of a legacy piece. The original flow processing pipeline was actually all Perl back before Logstash was a thing. It was all authored at IU. And over time, we've basically taken pieces of that and given them back over to Logstash. And so really the importer now is just a custom script that um, it's the piece that discards the flows that are under 10 megs in size that we're not interested in, and it really just does a couple minor modifications to that flow data to format into something that Logstash is willing to accept. So its role has kind of gone down from being the entire pipeline to just a formatting tool that gets everything ready for Logstash to ingest.
Yeah, I think it's about 100 lines of Perl at this point. The heavy lifting is all done by Logstash and then the NetFlow D.
The SNMP piece, which we have certain networks that are giving us SNMP data as well, is very, very similar, but it was actually developed by ESNet for Stardust. And Stardust was kind of born out of the NetSage approach to things, but they decided to author a very specific tool for their needs that is a little more technical in nature, and it's a very, very powerful network analysis tool. We are borrowing the SNMP ingest portion of that because the way we were doing SNMP was becoming outdated, and we liked the approach that ESNet was doing. So as opposed to trying to reinvent a very specific wheel, we're just using that container. So very much a similar type of thing. We get SNMP in, it gets stored, gets processed in a pipeline, and then stored in Elastic and visualized in Grafana. So the for the visual people out there, the NetSage architecture looks a little something like this. Basically, all of the heavy lifting of the preparation happens on your site. And then at TACC, we're just doing the storage, which is kind of cumbersome because you've got a lot of data to store. Need some horsepower behind it to generate queries and stuff. And then the dashboards themselves. So with Globus,
Hey, Doug,
um,
one
yeah,
more question came in
sure.
before you get off of that.
Yeah.
Why Elasticsearch and not something else?
Because Elastic was basically it in terms of uh, a large number of records that needs to be searched in a very short amount of time. When we started developing NetSage, some of the other tools that are out there now didn't exist, and we needed a way to be able to parse and search, billions of records in a very, very short amount of time, so that we could generate visualizations in a very, very short kind of real time scenario. So if you set the Wayback Machine to about 8, 9 years ago, there really wasn't much else on the landscape, and so we have a very large archive of data going back a long way. And while there are other tools out there that are pretty solid, the conversion process and remaking everything to use a newer, different tool like Stack or ClickHouse or something like that is probably outside the scope of anything we're honestly interested in doing. So with Globus, they approached us and asked us, "Hey, we've seen what NetSage can do. We've been at a couple different conferences. What would it look like if we gave you some Globus data to play with and see if you could visualize that instead?" So they gave us about a year's worth of data to play with. Back, I think it was like June of 2022 to June of 2023 or something along those lines. And basically, it was one big 5.7 million line CSV file. And when we looked at the format they gave it to us in, source, dest, bytes, files transferred, start time, end time, we're like, this looks a lot like a flow record. And so Brian came up with the idea of, hey, why don't I just knock out a Python script that will take this CSV file and reassign the fields a little bit and make them look like a flow file that's already in JSON format, because JSON's extremely friendly for feeding into a Logstash pipeline. And so that's what happened. And Brian, I don't remember, but that script's not particularly long. It might be, I don't know, 60 or
No,
70 lines or something.
yeah, 50 lines maybe.
Yeah.
It's not complicated.
So we basically just fed it and said, hey, turn this big CSV file into a big JSON file, and we let it rip. And I don't know, it was probably a couple hours later, we had a completed file that we tried importing. And really, it, it just kind of worked. Is the we had to tweak one thing, I think, and we did another import after that, and then all of a sudden I looked in Elastic and I could see data. It was formatted properly. Everything was there. All the field names were filled in that we were expecting to be there. It ran through our pipeline without any kind of problems whatsoever. Once we worked out just a couple small bugs at the beginning. So we were able to visualize that data and then share that exclusively with Globus. We didn't share that out publicly or anything like that. And based on that, we started having conversations about, well, what would a regular data ingest look like? And so we're actually looking at the clock right now. It is 22 after. So at 2 o'clock every day, I do an import here locally. Basically, we have a sync set up between a Globus collection that they maintain, and we just sync it to one of our collections here at TACC. Happens automatically about, I think I've got it set up, it runs around noon every day. And then at 2 p.m., cron job basically pulls that file, runs it through the Python script, and shoves it into the Elastic database. So pretty simple flow pattern here. There's not a lot to it. And it kind of basically made sure that we didn't have any necessity for a collector or any of the things that we normally need for flow data. It was literally just the pieces of the pipeline from Logstash forward. So that really simplified what we needed to do on a day-to-day basis to get this data put in there. I touched on this a little bit when I was showing off dashboards that to maintain privacy, we go ahead and de-identify flows down to the low order bits. Globus is already doing that because they're sending us this file. It's a plain text CSV, but they don't want to give out direct endpoints either. So to make it work with the pipeline, I said, well, why don't you just make everything a .1? So whatever the first 3 octets are, leave them alone and just give us a .1. And then when we run it through our pipeline, it looks like a valid IP address, and our pipeline does what it normally does. It replaces the last part of the IP address with a .x. So you'll see that when we're looking at flow data or Globus data later. So it's already pre-de-identified, and then we re-de-identify it just to make the pipeline work. The entities that we talked about that have sensitive intellectual property, we just had Globus set the IP to quad 255, which is technically a legal IP address, but it's a broadcast address. You're never going to see traffic on that in the wild. So if we see that IP address, the pipeline just grabs it, tags it as unavailable, and we move on with our lives. But we do like the fact that we still have the complete data totals in there so we can see transfer totals and we can have those reflected when we're looking at average transfer rates. We can lump all that in as well. So the Logstash modifications were really pretty trivial. Again, we're going direct from JSON as opposed to doing an input from RabbitMQ. We're not throwing out any tasks smaller than 10 megabytes because part of the reason we did that was for like I said, some privacy PII's sake, but also we found out with flow data, if we throw out everything under 10 megabytes, we throw out 95% of the flows, but we keep 95% of the total volume that the flows represent, which means when you throw out the small stuff, you get rid of the raw number, but you keep the big elephant flows. You keep all the data that you're actually looking to mine. Well, with Globus, we're only getting completed transfers. We're not getting individual flows, so there's no reason to throw out the small stuff anymore. The pipeline also stitches flows together from those NFCapD files. Those get collected every 5 minutes. Well, if a flow is longer than 5 minutes, we obviously need to stitch that together to show a whole flow. We don't need to do that anymore because Globus is giving us complete records. And then we just had to add one additional Logstash pipeline to process that quad 255 address. So really pretty trivial modifications on our part. More of the work went into changing the dashboards around to be able to display this Globus data in a fashion that makes sense and to take advantage of some of the features of Globus data that we don't have with flow data. In fact, you'll notice the pipeline here looks strikingly similar other than it's just Globus over here. It's not SNMP and flow, and we eliminated some pipeline stages. Other than that, very, very similar. So dashboard updates, Brian is going to take over after this slide, and he is going to show us how this all works when we're mining for interesting information. But you'll notice if you've used that NetSage before, the dashboards are stripped down a little bit. You don't have a sensor because we're not dealing with multiple flow sensors. It's literally just Globus data. Scope was basically something we used around domestic versus international transfers, which we have more of in flow data. We don't, it turned out to not be interesting at all in this context with Globus, so we just eliminated it. Test data, perfSONAR, we're not doing perfSONAR over Globus, so that option disappeared as well. And we do have the confidential data toggle added so that you can see data totals if you are interested. We also have one other thing that we added right before this presentation that's not here. We have an internal transfers toggle that I showed off earlier. So we had to do that. We had to remake pretty much, I think I touched every query from every Globus dashboard to make it work. But the format was more or less the same. So while the dashboards kind of just worked when we fed them the Globus data, we spent a lot of time thinking about how Globus data was different and the best way to present it.
Hey,
So,
Doug, one other question before you switch off to Brian. Is the
sure.
data time dependent, meaning does it stitch data based on time windows?
No, it actually, what we do is based on it's effectively a modified five tuple. So you've got your source and dest IP, source and dest IP, source and dest ports, time, and then we also add in one other factor. We generate a unique flow ID, and then we match all those flow IDs together in the pipeline to create one actual final flow when it's done. So we're basically doing some tagging up front based on a five tuple match, and then that's what gets stitched.
But for the Globus stuff, that's a non-issue, right? I mean,
Yeah, don't need that at all. Exactly.
but for flow data, that was a fair amount of work early on. Okay, well, I guess I'm going to just jump in and give a few more specific examples that I thought were kind of interesting. As Doug showed, to change the time window is up there in that corner. I'll do 90 days here for a bit. Top sources and destinations, as Doug showed, and again, if you turn on the confidential, there's a fair amount of data is to one of these confidential sites, but
Well, and that may be multiple confident. It all gets lumped into one.
right.
So
Oh
we look
yeah,
at say how many sources that actually represents.
we Globus folks haven't even told us how many sites fall into that category, because even that's confidential, right? But we just we get the data from them, and it's already been stripped out. So let's start with Oak Ridge, obviously one of the top Globus users internationally. I guess since I asked for 90 days, it's going to take a little while. And again, Doug mentioned a lot of people use Globus internally, and Oak Ridge in particular does that. So we turn off internal transfers, and you see that changes quite a bit. I think it's really impressive what kind of numbers they're getting in and out of Oak Ridge, and in particular between Oak Ridge and NERSC. Peak transfers of over 100 gig per second, and average transfers of roughly 20 gigs per second is between those sites is quite impressive. Actually, if I turn internal back on for a sec, look at that. Over 250 gigabits per second for a transfer. That was one of 1,500 tasks in that window. So clearly Oak Ridge has done a great job architecting their DTNs, and clearly Globus does a great job of taking advantage of that. So if I click on, let me think, yeah. Okay, let's go to Argonne next. So this is tasks between Oak Ridge and Argonne. it's just so interesting to see the wide range of types of jobs that they're clearly doing between these two sites. You know, sometimes people are transferring over 1 million files in a go. Sometimes people are transferring 5 files in a go. You know, the rates vary all the way down to the kilobits, but of course, Globus works on people's laptops. So, well, actually, this one's a failed test. If it says 0, I guess like maybe I can click on that. Right? You can click down to the individual flow level and get all the detail. And in this case, the task didn't even succeed. So I guess the performance is not expected to be very good. It probably timed out. But going back, it's interesting to see that they have some workflow that transfers the exact same amount of data in chunks of 500 files that runs on a regular basis. Performance for those vary from roughly 65 to roughly 25. So, you know, again, to be expected, there's shared users, there's other people using the disk, there's other people using the network. And then at some point, they might have changed their workflow. Because if you go back in time, yeah, this is back in time. All of a sudden, rather than 500, 500, you get 100, 100. So I don't know if that's, you know, somebody at that end was doing a little bit of tuning and tweaking. I think maybe their rates did get a little bit faster when they did batches of 500 files. But, you know, these are the types of things you can look at with these new Globus dashboards, which before would have been very, very, very difficult to get any insight on what was going on your site and how people were using the Globus software. Let me, oh yeah, I scroll all the way down. You get these heat maps that kind of show bursts of activities. So, you know, clearly Oak Ridge and Argonne were running a whole bunch of stuff back here. And then since then, there's just been a couple really big bursts of data. So going back to the beginning. Another interesting example I thought was University of Hawaii. Let's go back to, well, let's do 90 days. Pretty impressive transfers going on between Hawaii and German Supercomputer Center. They transferred 28 terabytes of data, 15 at a chunk. And I click on that. And these are pretty impressive rates from Hawaii to Germany. That is a very, very, very long path. And they were getting basically 5 gigabits per second average transfer for those. So that's again, so no doubt somebody spent some time doing some tuning of these things, because you're not typically going to get that kind of stuff just out of the box. Let's see, we can just look at another random example or semi-random example. University of Minnesota. And they also, well, let's turn off internal transfers just to make sure. Yeah, they also have a fair number of internal transfers. So it looks like University of Minnesota's main endpoint is TACC. But you can tell they do a lot of different research in a lot of different fields. At a lot of different rates. You know, some of the sites clearly aren't getting very good rates. That's just one task, but oh, I've lost. I'm not. Let me get back to 90 days. You know, so if you want to, if you work at University of Minnesota and want to figure out who could use some help tuning and testing, you can go in here and look and see that, here's transfers going on to Cornell, and there's 113 tasks, and their data rates aren't very good. Now, who knows what they need? Maybe that was a laptop. Who knows? But you can kind of go in here and dig around and say, why aren't they getting better performance than that? I think they should be getting better performance. And you can try to figure out who's doing the transfers and work with them to tune their end hosts and things like that. Let's see, I will show a couple more things and then hand it back to Doug. So top tasks by science discipline is kind of interesting. Let's see again, let's do 90 days. And this is where the science registry comes in. Doug's going to talk a little bit more about the science registry in a minute. But in the science registry, we're tagging certain subnets as what field of science they're doing, whether it's astronomy, physics, etc. Let's turn off physics for a moment and maybe click on those two. And you can see the data coming and going. This is all Globus data, all organizations, who's, of the stuff that's tagged in the science registry, who's talking to who are the top pairs. So just give you an example that some of the extra stuff you can do with data that's tagged in the science registry. Yeah, here's the summary across the science disciplines. So supercomputer to supercomputer is the biggest use for sure. That's typically these tags are the supercomputer centers, both DOE and NSF supercomputer centers, followed by atmospheric. They're doing a ton of data as well. We'll show the summary page. And let's do 90 days. So this is sort of the sum of everything going on. The average task rate is a little more than a half a gig, which is, not bad when you consider the wide variety of stuff going on here. Not a lot of IPv6 yet. I think Globus only recently started supporting IPv6, and apparently not a lot of people have switched things over. Or if they have a dual stacked host, it ends up showing up as an IPv4 task in the logs. And the other thing I wanted to point out is tasks with only one end in the science registry. So this is the kind of thing where if you see your site in this list and say, oh, well, I'd really like to know more details about what department at my university is using, that's the kind of stuff we can add to the science registry, is that you let us know what subnets are part of what resources. That's where you can get this additional information. And Doug's going to show a couple more examples of that when I finish here. Yeah, and then let's see,
So there was a demo-related question before you pop out, Brian,
okay.
from Nick. Regarding the Hawaii to Germany transfer. Does NetSage obtain or provide any context on the paths?
No. Okay. That would be nice.
That's where we hand that off to your local data resources, or taking a peek at perfSONAR or something along those lines.
Yeah, I mean, the closest thing I'm aware of that could help with that is you could dig around perfSONAR land, and if there's a perfSONAR endpoint at the perfSONAR node at the two endpoints and they're running regular trace route tests, that data may well be available. And that's part
since
of
we're showing since we're showing the subnets, you've got the ability to know if you're in the right ballpark at least.
Right. One last thing I thought I'd show that's kind of interesting. We've been collecting flow data for a long time, but let's see, where did this go? Maybe I have to hit a refresh on this. Um, you can you can dig through the flow data. Okay, so here's what we used to see with the older NetSage. Some transfers between NCAR and the University of Hawaii, right? And there's just many, many, many flows that are getting, 60 megabits per second, and each flow is about a gig. But in comparing that, I went and put in the same time range in the new Globus logs, and all of those little flows are summarized in these two Globus tasks, which are getting a very, very impressive 28 gigs per second. So, this 546 files, there's enough parallelism going on that you get, 100 or so flow records that look pretty unimpressive in terms of throughput. But when you realize, which you don't have the view of in from the NetFlow records alone, but by correlating that with the Globus logs, you'd say, oh, well, that's actually a very respectable transfer going on. So I
Yeah,
thought that was
that's
interesting.
a caveat we've always had to give to people when they look at individual flows in NetSage is, well, the performance of a lot of these doesn't look good. And it's like, well, if you sort by time, you can sort of infer, okay, you have all these transfers kicked off, they're about the same size, and they started at about the same time. That's probably a good example of, Globus using grid FTP, that type of thing. So it's interesting now that we're able to kind of dig around like Brian has done and go, well, that actually is apparently what happened during this time frame.
Okay, any other questions on what I just showed before I hand this back to Doug?
Not right now.
Okay, we're going to talk quickly about kind of what's next, and uh, we'll talk about the science registry because this will play in heavily to what's next and what Brian was just talking about. So the science registry is user contributed data that lets us more specifically tag flow and Globus information. So basically, it's kind of like DNS, but for resources. So we know that this specific IP range represents a compute resource or a DTN cluster or any number of things. And then we can put that into the science registry and we can tag the data with it while it's in the pipeline. And so again, this is all contributed by end users. This isn't something we go out and scrape data for. We're not Googling to find out what resources are. We're not pinging addresses, nothing like that. This is a purely you want to contribute because you want your resources better represented in NetSage. You get a hold of us, and Brian's actually really done some amazing work to pare this down. It used to be a very, very large um, database, not in terms of number of records, but in terms of the information it collected and the pieces and parts of it. And we took a really hard look at what we were actually using to tag data, and Brian was able to pare it down to this relatively small blob of JSON per record. If you go head to that website, netsage.io/science registry, you can see the template there. You can pull something to fill out and then email it to us, and we will include it in the next version of the science registry we kick out the door. And there's no rhyme or release to how we release that. There's no, well, it'll be in there next year. I mean, if we get a bunch of information from you, we're probably going to kick it out the door the next day because we want to start tagging that as soon as possible.
Yeah, there's also a
So
link to the full JSON file at that URL, so you can download and look for your site and see if it looks accurate.
yep, perfect. So I'm going to show you real quick. Let me go ahead and drop this again, and we're going to switch gears one more time because why not? Why this matters so much, at least from a visualization standpoint. So this is actually on our dev site. This isn't live. You can see Epic Grafana dev. Sorry, not available to the public. This is our flow data for projects. So I chose the flow site because we have more data tagged for flow in there than we do for Globus, so it made it look a little more interesting. But this is 90 days of what we're considering to be data that's associated with the Atlas project. And when you tag it just by organization, it doesn't look particularly interesting because TACC, as an organization, we have a bunch of different resources, but that all gets labeled under TACC. And in fact, one more thing about that, TACC actually exists in University of Texas IP space. So if you just do a geo IP lookup on our IP space, it's going to come back as UT Austin. We actually have TACC in the science registry. So as an organization, it shows up as TACC. And I know there's a lot of other entities out there that are similar. I think there's some labs that actually their IP space exists inside of ESNet's space, and there's a couple other examples like that where if you're an entity that is being masked by a larger entity, you don't have to give us specific little tiny resources to put in there like a perfSONAR box. In fact, we'd prefer you didn't. What we are interested in is can we pull your entity out and actually give you a view of your data not being overshadowed by the entity that owns your IP space. So this dashboard here, again, it does show you interesting information about the transfer patterns in this particular project for Atlas. But if I take this same dashboard and I say, well, I want to see what that looks like by resource as opposed to by organization, all of a sudden it's more interesting because you can see the different flows between different systems and different entities, all kind of in a mix here in the dashboard. If we don't have more specific information about a specific entity, then they will just be the larger name. They'll be ESNet, they will be TACC or something along those lines. But if we have that information in the science registry, we can see that that was from Frontera or that went to Ranch is our tape archive. That's where our long-term bulk storage is. Lone Star is our GPU cluster. Stampede 3 is our primary access resource. So we can start to see when you talk about science registry data by project, it's really more interesting if you can look at it in terms of what resources are in use as opposed to just which organizations are in use, including organizational pairs here. You can see what the total throughput was, largest flows, average rates, all that stuff broken down by resource. So we do want to know what resources you have that are involved with what particular science and what particular projects so we can map those. But even if you don't have that level of information, even if you can give us information that just says, well, here's the specific resources. I can't tell you what science they're tied to specifically, but we at least have these resources out there that are used by a bunch of different disciplines. We can break it down that way. We're figuring out the best way to use this resource data, which is why a lot of this isn't live yet, but we're playing around with different ways that we can look at this. So this is a dashboard I kind of built this week, just playing around, trying to see how we would use this resource data most effectively out there. So I've got TACC pick as our organization, and then that breaks it down further into what resources TACC is advertising, which ones we have in the science registry. And so we can look at it as a whole and we can see resources by destination and by source and destination, by rate and volume. And we've got an ESNet chord chart down here that's been developed for the visual people that want to see, sources and destinations and how things are being distributed. Thicker lines, thicker arrows mean there's more data, or fatter lines over here mean that there is a higher data rate. But if you're only interested in a specific resource, let's go ahead and say Lone Star, because I think that'll bring up a smaller amount of data just so we can kind of pare these charts down a little bit and we can have a clearer picture of which resources are in play. So again, this isn't in production yet. We're kind of working on the next round of NetSage dashboards and what those might look like. And this is one possibility of how we're going to be showing this data moving forward, because it is useful to be able to get down to a specific resource, but it is also nice to be able to look at them all and then kind of see the distribution between resources and how they're being used. So that's definitely my plug for the science registry. If you are at all interested in contributing, you can go to that web address that Brian had on that slide and get started. And if you're not sure about something, you're not sure how it should be broken up or how it should be labeled, just get a hold of us, drop us an email, epic@tac.utexas.edu, and we will, help you sort that out. This is designed to be a resource for everyone to use, and so we want to make it the very best that it can be. And one other thing that we are kind of playing around with right now. I've got one last slide on this, and I'll stop torching you with slides. So we took a stab at ingesting our own local Globus task logs as opposed to getting the ones from what we lovingly call the mothership. We store them all in Splunk, and it turns out they're a netlogger format, which Brian spearheaded years ago, still in use. And while the formatting of them was different than what we were getting from Globus, we also, because it's local, we get more information. We get usernames, we get jobs that are associated with it. You get a lot more information than what you get out of a public site. And so we're looking at ways to possibly use this data to tie NetSage a little more closely to our cluster management and our job management. So can we use NetSage to not only look at flow data and Globus data, can we use it to kind of look at the life cycle of a job as data comes in, the job gets processed, the data it goes over here for storage, and then it gets picked up somewhere else and transferred back out. Can we look at a job as a whole and use NetSage to visualize something like that? So there's a bunch of interesting implications once you start ingesting different formats of data about how you can put it together and get different views of what's happening in the R&E ecosphere. So that's what we have for you today. I think there's a few minutes left if anybody has any other questions.
All right. Well, thank you guys. Most of the questions have been answered. One comment from James was that when you're ready to start doing the IPv6 flow label stuff, he has some Python code that he may be able to contribute. And Jen shared the email. So James, I'd say just shoot an email to there. And one other question here: do you get data from Globus in a streaming manner?
No, it's once every 24 hours, they basically bundle up a CSV file and drop it in a Globus collection. And then that collection automatically syncs to ours, and then we process that file once it arrives. So the data we have today is a summarization of the data they received yesterday. So we're about a 24-hour gap back. There was one other thing I was going to answer. Who was that? Andy, you asked about Argon and the list and the double Argons. So the one with the parentheses ANL, that was tagged in the science registry. The other one without the ANL was tagged just with GeoIP data. So that kind of highlights part of what we're trying to work through in the science registry right now is we probably have a couple of your IP ranges in the science registry, but not all of them. And so as we're grappling with the best way to display this data, we've found a couple instances like that where there are two organizations. So I'm going to be implementing some fuzzy query language that basically says if it looks like Argonne National Lab, then we will just summarize those all in one.
Yeah, it's interesting you noticed that because we literally noticed it for the first time like 3 hours ago.
This Globus stuff is all still new to us too. So.
Yeah, and along those lines, I'll put the plug out that, if you are willing to help these guys, certainly shoot a note to the link, the email address that Jen put in the chat room, epic@tac.utexas.edu. One other question here: does the data only cover Globus subscribers or any user of Globus?
I don't have an answer for you on that. I believe, based on what I was talking with a couple people at Globus about, this just covers all of their transfers. So if you're just using the free version of Globus, not the paid for version, this covers data they're moving with that as well. But I will find that out for sure because I'm only about 85% sure on the answer I just gave you.
Or is there a Gold Globus person on the call who knows definitively? I'm not sure.
There actually is, and Lev just unmuted, so go for it, Lev.
Yeah, I will not say definitively, but I raise your 80 something percent to 95, 99.
There you go.
Yeah. Transfer is free. So this is not for subscribers. And we don't cater to just subscribers.
All right,
So
thanks,
this
Lev.
should be
All right, a couple minutes left. If anybody has any questions, I did unmute everybody, so if you want to raise your hand or unmute or type it in. And while we're waiting for any last questions, thank you guys again. I'll make sure I get the slides and the video posted. We're not going to have another talk until October 11th, and it's Brian again, talking about his other side gig,
Yeah,
busiest retired person I know.
it will be that will be mostly my collaborator Marcos from RNP doing the talk. But yes, it, it is work that the two of us did.
Okay. Okay, and Andy was just pointing out what we were talking about with the multiple argons.
Mhm.
Okay. Well, thanks everybody. We'll get all this stuff posted, and we will talk to or see everybody in a couple of weeks. Hope you all have a good weekend.